Okay, so consciousness, right? What is it? Where does it come from? That feeling of you. It's a question that's puzzled people forever, and this deep dive. Well, let's just say it takes us to some pretty wild places. We're talking quantum biology.
Yeah, it's easy to take our conscious experience for granted.
Totally. We think, we feel, seem simple. But then try explaining how a physical thing, even a brain, creates those feelings, that self-awareness. It gets complicated fast.
No kidding. Most folks think brain's a computer, neurons are like on-off switches. But is it really that simple?
And that's what Dr. Stuart Hameroff, an anesthesiologist, really started digging into, which I got to say is interesting in itself. You don't always think anesthesiologist and then philosophy of the mind.
It's key, though, when you think about it. He's basically a consciousness switcher, on, off, all day long in the operating room. So that experience made him question that whole brain as a simple computer idea.
Right, like those cartoon neurons we see in diagrams. That can't be the whole story.
Yeah.
A switch on a circuit board can't feel what it's like to read a good book, can it?
Absolutely not. And Hameroff, he points to things like paramecia, single-celled organisms. They swim around, find food, avoid danger, even reproduce, all without a complex nervous system.
Like we assume bigger, more complex means smarter. But those tiny things are doing incredible stuff. What's happening at that level is amazing.
Exactly. And for Hameroff, a big part of that is these things called microtubules. They're inside all our cells, but tons of them in our neurons.
So microtubules. Most of us probably picture them as like scaffolding inside the cell, right? Holding things together.
That's the usual idea. But early on, before he was even focused on consciousness, Hameroff saw something interesting about how they're structured. They're in this lattice formation, a complex network almost.
Like a biological superhighway of information.
Right. He realized it was similar to computational networks, the kind we associate with processing power. And that's when it clicked. Maybe microtubules are holding and processing way more information than we thought.
So we've got these tiny microtubules potentially packed with information, and it really challenges that idea of the brain as a simple computer.
Yeah.
It's like zooming in on something that seems smooth, and suddenly you see millions of tiny parts all working together.
It is. It's a huge shift in perspective. And that shift led Hameroff to the work of physicist Sir Roger Penrose. Penrose was tackling something called the hard problem of consciousness.
Which is?
Well, it's the question that's been around forever. How do physical processes, like neurons firing, create subjective experience? Like, how do we explain what it feels like to see a sunset or hear a song?
Right, you can map out brain activity, but how does that become the taste of chocolate, the feeling of joy? Tough one.
Exactly. And Penrose said, look, consciousness can't just be regular computation, no matter how complex. Neurons firing like bits in a computer, that's not enough. He thought we were missing something from the quantum realm.
Quantum mechanics. So now we're saying the answer to consciousness is in the subatomic world. That's a deep dive.
It might sound like a leap, but Penrose's idea was this. Quantum mechanics, it's all about the weird behavior of particles at the smallest level, right? Superposition, entanglement, the really strange stuff. And he suggested that these quantum processes, way deeper than neurons, could be where consciousness comes from.
Instead of just neurons, there's this whole other layer of quantum stuff happening in our brains, affecting our thoughts and feelings.
Yeah. And it's not just in the brain. Penrose connected it to the universe itself, to space-time geometry. He said consciousness comes from these quantum processes that are tangled up with the structure of space-time itself. It's like our brains are tapping into something fundamental.
So it's not just that we have a brain, but that brain is intertwined with the universe on this quantum level, and that's consciousness. Mind-blowing.
It's a radical concept. And when Hameroff came across Penrose's work, he was immediately hooked. Remember, he was already saying microtubules had to be doing more than just providing structure. Penrose's ideas were like the missing piece.
So both of them had these big radical ideas, and then suddenly, boom, it all fit together.
Exactly. Hameroff saw that microtubules with their unique structure and potential for quantum processes might be exactly the kind of quantum devices that Penrose's theory needed. Like two pieces of a puzzle finally clicking into place.
Okay, so we've got Hameroff, we've got Penrose, each with these really out there ideas. What happens when those ideas actually meet?
Well, that's when things get really exciting. They team up, right? And they develop this theory. It's called orchestrated objective reduction, or ORCH or R. It's their attempt to explain how consciousness could actually come from quantum processes inside these tiny microtubules.
ORCH. Or. But, okay, what's actually going on in our brains, according to this theory?
So imagine this. Inside the microtubules, within your neurons, there's a ton of quantum computation happening. And these computations, they involve those strange quantum states we talked about, like superposition, where different possibilities can exist all at the same time.
So it's like our brains are exploring multiple realities at once, at this quantum level.
You could say that, yeah. But it gets even wilder. These quantum computations, they don't just go on forever. Eventually, they collapse into a single state. Penrose calls this objective reduction.
A quantum collapse. Okay, so what does that feel like? Is that what we experience as like a moment of consciousness?
That is the core idea behind ORCHR. The theory says that these quantum collapses happening in microtubules all over the brain, all linked up through entanglement, those are what we experience as moments of conscious awareness. Each collapse is like this tiny spark of subjective experience.
So it's not just that we are conscious, but consciousness itself is happening in these little discrete quantum moments. Our brains are constantly flickering with these tiny bursts of awareness.
Exactly. And you know how we talked about anesthesia being this big clue for Hameroff? Well, ORCHR might actually explain how it works at the quantum level.
Yeah, that was a big one. Anesthesia can shut off consciousness, but other brain functions keep going.
Yeah.
How does ORCHR fit in?
Well, the theory is that anesthetics, the drugs that make us unconscious, they might actually be disrupting the quantum processes inside those microtubules. Basically, they stop those orchestrated quantum collapses from happening.
Anesthetics are like muffling those tiny quantum sparks of consciousness. No collapses, no awareness, just like flipping a switch.
That's the idea. And that connection to anesthesia, the fact that a drug that messes with consciousness also seems to mess with quantum stuff in microtubules, that's some of the most compelling evidence for ORCHR.
It's wild to think something as, every day as anesthesia could be our window into the quantum world of consciousness. We've gone from neurons as simple switches to this whole universe of quantum events happening inside ourselves. What else could be out there?
Right. ORCHR really makes us think about consciousness in a totally new way. It says that maybe consciousness isn't just some side effect of complexity, but a fundamental part of the universe, coming from the quantum world inside each of us.
And if consciousness is part of the fabric of reality, like Hameroff and Penrose say, what does that mean for us? Our understanding of the universe, how life began, could there even be consciousness beyond the brain? This deep dive has given us a lot to think about.
Huge questions, the kind that'll keep philosophers and scientists busy for a long time. ORCHR might not have all the answers, but it opens up so many possibilities, makes us look beyond what we think we know, and consider something truly amazing. That the biggest discoveries about the mind might not be out in space, but right here in the subatomic symphony happening inside every single one of us.
It's a pretty incredible thought to end on. The next time you have a thought, feel an emotion, take a second to appreciate the quantum dance happening in your own brain. There's a whole universe in there. And who knows, maybe the most incredible discoveries about the human mind are waiting to be found not in the distant corners of the cosmos, but in the subatomic symphony of our own being.